today we're doing more work with equations. This is on page 143. Basically, when you have an equation, if you have something like this, you need to combine like terms and then try to get the variable by itself. So 3x and positive 5x are like, so that's going to be 8x, and then positive 2 and negative 7 are alike. So you have to combine those to get negative 5 equals 28. Then do the inverse to get 8x equals 33, and then x equals 33 over 8. I'm not going to do the check right now, but if you took the 33 over 8 and plugged it in for x and did that out, you should get 28. Okay? All right, here, what do? Hopefully you look at this and you go, oh, I have to distribute that 4. Anything sitting outside of parentheses, whether it be a negative, a number, a negative and a number, whatever, the whole thing has to go to everything on the inside. So we're going to get 4x plus 20 minus 3x equals 24. Combine like terms, 4x and negative 3x is 1x plus 20 equals 24. Subtract 20 from both sides and you get x equals 4. Plug it back in and see if it works. Example 3 is in the book. John's mother is 4 times as old as John, and John's brother is twice as old as John. If you find the sum of their ages and add 3, you get 80. What is the age of all 3 people? Okay, so let's let x be John's age. If x equals John's age, it says John's mother is 4 times as old as John. So the mother is 4 times as old as John, so she would be 4x. If you find the sum of their ages and add 3, so the sum of their ages is 4x plus x and add 3, then you will get 80. Okay? So 5x plus 3 equals 80. 5x equals 77. And then, because I subtracted 3 from both sides, x equals 77 over 5. Okay? Where's the problem? Nope, I did it wrong. What did I do wrong? Oh, I forgot something. I'm sorry. I forgot about John's brother. John's brother is in there too. That's the problem. Sorry about that. It says John's brother is twice as old as John. So if John is x and he's twice as old, the brother is going to be 2x. So now add all 3. John plus his mother plus the brother plus 3 equals 80. 4, 5, 6, 7. 7x plus 3 equals 80. Subtract 3, that's the inverse. 7x equals 77. X equals 11. You actually have to go back up and say John's 11 years old, the mother is 44, and the brother is 22. All right. Example 4 is convert 2.3 with a repeating decimal to fraction form. Okay, this is going to be a little weird for you, but we have to try to get 2.3 out of there. We don't want to be working with a repeating decimal. So the first thing you're going to do is you're going to let x be the repeating decimal, 2.3. Now let's get one of the things with the repeat to be in part of our problem here. So if we multiply 10 times x, then we will have the 2 and the 3, 23, and then the repeating decimal. Once we get that, if we let x equal 2.3, we can subtract x on this side, 2.3 on this side, and that actually eliminates the repeating decimal. 10 minus 1 is 9. 23.3 minus 2.3, those cancel, you get 21, and then x equals 21 over 9, or 7 over 3. Okay, the last one is over here. This is a repeating decimal. Convert 7.292929 to a fraction form. You're going to first let x be the repeating decimal, 7.29. Now, don't look down here. What could I multiply by so that I can get the 7, the 2, and the 9 to be on the left side of the decimal, and then the repeating stuff on the right? Well, you can multiply by 100. That would move the decimal point twice. If you multiply by 100 over here, then you multiply by 100 over here, you get 729.29 with the repeat. Okay, now if I subtract x on this side, x is equal to 7.29. If you notice, those 0.29s are going to cancel. 9 minus 7 is 2. 2 and 7, so 99x equals 722. Divide by 99 on both sides, and you get x equals 722 over 99. That cannot be reduced. Okay, it's a little tricky, but it's doable. So you guys are going to do sections on page 145 and 146, numbers 1 through 29. I will be checking notebooks today, so get ready. Thank you.